We previously examined area. Now we're going to look at volume. This is section 10.5, volume and surface area. Objectives: use volume formulas to compute the volumes of three-dimensional figures and solve applied problems. Compute the surface area of a three-dimensional figure. We're going to start with some formulas for volume. The volume of a rectangular solid, think of a box, V, is the product of its length, its width, and its height. So volume is equal to LWH. If you look at the pink figures below, if it's a rectangular solid and you know the length, the width, and the height, then the volume is the product of those three. If it's a cube, you can do the same thing, but since length, width, and height are all the same for a cube, the volume is S times S times S, or S cubed. The figures on the right show a cubic unit, and it's showing you that if you've got a length equal to 3, a width equal to 3, and a height equal to 2, then you can figure out what the volume would be. You could, if you had these blocks, you could do this by stacking blocks and then counting the blocks. So for this particular figure, you see that the base part of it is 3 times 3, which is 9, and then the height is 2, so the volume of that would be 18. Example 1, solving a volume problem. You are about to begin work on a swimming pool in your yard. The first step is to have a hole dug that is 90 feet long, 60 feet wide, and 6 feet deep. You will use a truck that can carry 10 cubic yards of dirt and charges $35 per load. How much will it cost you to have all of the dirt hauled away? Well, in these problems, always look at the units of measure and make sure they're the same. If they aren't, then you need to convert one measure to the other measure. So for this solution, we're going to convert feet to yards. 90 feet is equal to 30 yards because there's 3 feet in a yard. 60 feet is equal to 20 yards, and 6 feet is equal to 2 yards. All of this is obtained by dividing by 3. Next, we want to find the volume of dirt that needs to be dug out and hauled away. So we're going to use our volume formula for a rectangular solid, length times width times height, which gives us 1,200 cubic yards. Volume is measured in cubes. Next, we find the number of truckloads by dividing the number of cubic yards of dirt by 10 yards, because 10 yards is how much it can haul each time. So doing this, we see that it's going to require 120 trips with the truck. They charge $35 per trip, so we're going to multiply the 120 trips times the $35. So this will cost $4,200 to get the hole dug and the dirt hauled away. Next, we're going to use a formula for a pyramid's volume. And you can see the shape of the pyramid. The volume for a pyramid is V is equal to 1/3 the base times the height, where B is the area of the base. You have to find the area of the base first, and then multiply by the height. The height is not the length of a side, but is the actual perpendicular distance from the base. For this problem, we're looking at the Transamerica Tower in San Francisco. It's a pyramid, and it has a square base. It's 256 meters tall, and each side of the square base is 52 meters long. We want to find its volume. We're going to see that the area of the base would be 52 times 52, which gives us 2,704 square meters. Then we use our volume formula. Volume is equal to 1/3 the area of the base times the height, which gives us 230,742 cubic meters. Next, the volume of a right circular cylinder. Think of a can. The volume is given by pi r squared h. Notice we're using the radius. So if you're given the diameter, you will have to divide by 2. And we use the height. So we want to find the volume of this cylinder. Has a diameter of 20 yards and a height of 9 yards. The radius is half of the diameter, which is 10 yards. We substitute the values that we know into our formula. Notice that only the radius is squared. So we're going to square the 10 yards, which gives us 100. 10 times 10 is 100. But the final answer is approximately 2,827 cubic yards. Don't leave the pi in there. You always want to multiply that out. Remember that pi is about 3.14 or 22/7. Next, the volumes of a cone and a sphere. The volume V of a right circular cone has height h and radius r is given by the formula V is equal to 1/3 pi r squared h. Remember, h is the height, not the length of a side, and r is the radius. The volume V of a sphere of radius r is given by this formula. V is equal to 4/3 pi r cubed. And this application problem uses both the volume for a cone and the volume for a sphere. An ice cream cone is 5 inches deep and has a radius of 1 inch. A spherical scoop of ice cream also has a radius of 1 inch. If the ice cream melts into the cone, will it overflow? The ice cream will overflow if the volume of the ice cream, which is a sphere, is greater than the volume of the cone. So we need to find the volume of each and then compare them. The volume of the cone, remember, is given by 1/3 pi squared h. And when we work this out, we get 5 cubic inches. So the volume of the cone is 5 cubic inches. The volume of the sphere, the ice cream part, is equal to 4/3 pi r cubed. Only the r is cubed. When we work this out, we get 4 cubic inches. The volume of the ice cream, 4 cubic inches, is less than the volume of the cone, 5 cubic inches, so there will be no overflow. Next is surface area. The area of the outer surface of a three-dimensional object is surface area. It's like wrapping a box for a Christmas present. Is measured in square units because we're talking area again. Volume is cubic units, area is squares. Okay, so the surface area of a cube is 6s squared, where s is a side. A rectangular solid, the surface area is the area of the different sides. So we have two sides that would be length times width. We have two sides that would be length times height, and we have two sides that would be the width times the height. So you find those and then you add them together. For a circular cylinder, like you're wanting to put a label on a can, but it would also include the top and the bottom. We have 2 pi r squared plus 2 pi RH. So the first part is going to be the area at the top and the bottom. There's a top and a bottom, so it's times 2. And then we use our formula for the distance around, which would be the 2 pi RH. In this example, we're going to find the surface area of a solid. We want to find the surface area of this rectangular solid that measures 8 yards by 5 yards by 3 yards. The length is 8 yards, the width is 5 yards, the height is 3 yards. Actually, it doesn't really matter, but usually the longest side is going to be considered to be the length, and then the height would be up and down. The surface area is 2 times LW plus 2 times LH plus 2 times WH. So substituting our values into this formula and then adding each of the results, we get 158 square yards. And that concludes this lesson.